Here is the second part of our completing the square formula. So here we have our polynomial ax second plus bx plus c equals 0. And here we have our completing the square. This is where we derived from the first lesson. Now it is possible to get to the quadratic equation from this point on. So this will be what, lesson 2? So here, let's rewrite this here so we can actually work with this. So we have x plus b over 2a squared and equal all this stuff here. So I'm going to have to write all that out. So we have b to the second minus 4ac all over 4a to the second. Okay, now what we want to do is we want to square both sides of these to clear out this exponent. So we're going to rewrite this again. X plus b over 2a squared. Remember, we're going to do this. Okay? And we're going to do the same thing on this side. So we're actually going to square this. So all over 4a to the second. Now, everybody knows that square roots cancel out exponents and vice versa. So basically, we are going to get this right here. This in return will equals this over 2a equals this whole thing here. Okay? For a to the second. Now, we can move this over here. Now, what I want to do is start cleaning things up a little bit. I want to get this all figured out and clean this up. So here we go. So first thing I'm going to do this all in one step. So the first thing I'm going to do is x equals negative b over 2a. Now since we have a square root, and we had this exponential thing, we're going to go plus or minus. And with the law of square roots, we're just write this out. So we're going to do b to the second here minus 4ac over 4a to the second. That's not too bad. Now let's go ahead and clean this up a bit more. So negative b over 2a plus or minus, now this can't be simplified, b to the second minus 4ac all over, now since we have this squared here, basically this right here is a square root of 4 and square root of a to the second. Okay, so, which would be 2a. Well, at least we have two common denominators. This will be easier. And pretty much now we have x equals negative b plus or minus the square root of b to the second minus 4ac. We write that like I care. ac. Now since both these have common denominators, we're just going to do this right here. Okay? And that's the quadratic formula. Now, a couple things that you can note about this. That wasn't too long, but in order to really make this really worthwhile for a lesson, we're going to talk about this right here. This piece right inside of here. So this is going to be our bubble right here. Right there. b to the second minus 4ac. Now, this is called a discriminant value. Now what the discriminant value does, this does tell us some information about this. Now if you're solving a polynomial and you have an instructor that says, solve the equation if there's a solution that exists, or how many solutions exist. Well, I'm going to run through this really quick for you guys and gals. So push that up a little bit. So there's a couple values that we have to note about here. So if this right here, and we're going to assume that this right here is whatever it is, if this value here, let's write it here. So let's pull this piece out. And by the way, this is our solution right here. Okay, to derive this. So let's take a look at the discriminant value. If b to the second, and I'm not going to write all that, you get the gist. Wow. That's why I'm doing these all unscripted. Getting all that nasty marker all over me. Okay, I'm just trying to think of a way to write this here. So we have b to the second minus 46. This is our discriminant. There's three values. And I'm just going to write it like this. B to the second minus 4ac. There's three values that we have to worry about. This is probably not legal the way I'm writing it, but just go with me now. Now, if this right here is less than 0, all right? If it's less than 0, that means that we have no real solutions. Okay? Just imagine if you put a number in here and this is like negative square root of 9. It would never work. We'll have imaginary numbers or complex numbers. Now, what if this right here equals 0? Okay? If this equals 0 right here, you'd only have just the b and the 2a. You only have what I consider one solution. And if we are greater than 0, that means we have, let me put some dividers in here. If that means we have two solutions. Boy, this marker really is trashed. So, the discriminant value, you know, especially if you're getting into secondary and high school teaching, this has a lot of value in here. So if you're ever teaching this, at least you can say, okay, if you were to present this to your students, how many solutions does this problem have? Or if you're learning this for your own math course, you know, you can just simply take this part of the equation here, which is just this. If you know this, this will tell you a lot. Okay, well, if there's no solution, you can skip on to the next problem, but if there's two solutions, well, you can just plug everything in here. I'll probably go more in depth on this. We'll run through some examples on this in a later lesson. But the discriminant value is the most important part of this whole problem right here. This right here. You could put this into a computer. If you write up your own computer algebra solving system, you can put that in there and it'll tell you too. So the discriminant value is a beautiful indicator. So this is an indicator. So let's run through this again for that really quick. This is the part of the solution. The square root here. If this is negative, if this right here was like -1, we just throw that out, unless we're doing complex, and that's beyond the scope of this. If it's exactly 0, guess what? Just one solution, because this plus or minus ain't going to matter. And if it's greater, well, we'll have two solutions. Very simple. So I hope this rough tutorial on finishing up completing the square to get the quadratic formula with an added bonus with the discriminant value helps out. It's a really beautiful problem just to solve something so simple, but hey, now you know. It took me a while to figure this out too when I was taking this back in junior high, but it's a really nice equation nonetheless.